Welcome to lesson 2 of 3 in this tutorial, covering pressure in gases. This is the second video in our series of 2 tutorials on the topic of particle model. Here are the key learning objectives for today's lesson. The first is to learn about pressure, and then we will look at calculating it with volume. Here are the AQA specification points for this lesson. Feel free to pause the video now and have a read through them before we begin. First, we will cover the compression and expansion of gases. Here are 4 key points we will cover today to do with pressure changes and volume. These are changes in volume, pressure rise, pressure fall, and force. First, we need to know that changing the volume of a container will affect the pressure of the gas inside it. As the volume of the container increases, the pressure of the gas inside it will decrease. In this diagram, we can see that as the container volume has increased, the pressure has decreased. Similarly, we can see that as there is a decrease in container volume, the pressure will increase. Our next learning objective is to use the particle model in explanations. A fall in volume is going to lead to a rise in pressure, as we've just seen. As the size of the container decreases, we find that there is less room inside the container. Therefore, the particles are contained within a smaller volume. As a result, particle collisions will occur more frequently, exerting a higher pressure within the container. The reverse of the previous explanation is true when the size of the container increases. There is more space, so less frequent collisions with the walls of the container, exerting a lower pressure. Pressure produces a force at right angles to the walls of the container, like this. As we learnt previously, when gas is trapped inside a container, it exerts a pressure on the walls. In turn, this pressure produces forces on the walls of the container. The forces are at right angles or 90 degrees to the walls of the container. This is explored in more detail in Chapter 4.5, Forces. It is important to understand the link between volume, forces, and pressure. This is an important concept that comes up quite regularly in exams. If you're investigating the effect of temperature or volume on pressure, you need to keep the other one constant. For example, if you're investigating pressure at different volumes, make sure to keep the temperature constant. Now let's look at our next learning objective, using a fixed mass of gas at constant temperature. We can calculate pressure and volume using the following equation. The constant does not change, assuming that the temperature doesn't change, which means if the volume rises, the pressure has to fall, and vice versa. You should practice using this equation. Exam questions may ask you to use it numerically or in terms of understanding, as demonstrated here. Now let's look at our final specification point, covering calculating the pressure of a gas. Pause the video now to have a go at this question. Using our equation, pressure times volume is equal to a constant, we can work out that B must be the correct answer. If the pressure is halved, the volume must double. We've now covered all the specification points for this lesson. Feel free to pause the video now and re-watch any of the sections you feel unsure about. We've now completed Lesson 2.